Well, black holes, we think, are spinning very rapidly. We see them in outer space with our telescopes, and we clock them traveling at around 1,000,000 miles an hour around its axis. We think that these spinning black holes do not collapse to a dot. That's the old picture. That's wrong. They collapse to a ring, a rotating ring of neutrons, rotating very rapidly, so rapidly it doesn't collapse onto itself. And if you put your hand through the ring, you do not die. You wind up on the other side of forever.
Even if you're traveling at the speed of light, that is insufficient energy to leave the area, to leave the zone. If you are in such a zone, and light doesn't get out, and light is the fastest thing we know about, nothing gets out. It is dark, and it is a hole. That is what we call a black hole.
Every galaxy has a black hole, and there's tons of stuff for them to be accreting that, as we've seen in binary star systems, when that gas is sucked in, it gets really bright and emits X-rays and optical waves and radio waves and everything. Why aren't these black holes doing that too? And the answer seems to be that they're only active about 1% of the time. So every galaxy has a black hole, but each one is only switched on or bright or actively accreting material 1% of the time. And in between, it seems that they blow out enough material that they sort of starve themselves, and that material has to accumulate in the center of a galaxy and trigger a new episode of activity. That's the guess. We don't get to stare at a galaxy and watch it evolve and see them switch on and off. You do it with statistics.
But the theory does say that you don't necessarily die when you go through a black hole, that there's a finite probability that you can go through it and perhaps go to a different point in space and time. The catch is that to build a time machine, to build a wormhole machine, to take you to a different point in space and time, requires the energy of a black hole.
As I approach the black hole, I will start to feel a gravitational tug on myself. It's a different kind of a gravitational tug or pull than you're accustomed to. Normally you think you're just pulled down. As you approach a black hole, that difference in pull becomes larger and larger.
As you get closer to the center, gravity will get more extreme, you will be squeezed and distorted. Spaghettification is the name some people use for this experience.
They're surrounded, this region where if you fall in, it's called the event horizon. And if you go across that horizon, then you are going to the center. There's one way of thinking about it, which is quite cool, which is that the time and space sort of flip is one way to think about it.
If you believe that the speed of light really is a speed limit, you can't go faster than the speed of light. A wormhole provides you a way, maybe, to still go slower than the speed of light, but get to where you want to go much faster because the distance is much shorter. It's really just a shortcut through space itself.
Imagine warping space and time in such a way that you can cut a portal from your location in space and emerge in another location in space.
But if we do not destroy ourselves, I believe that we will one day venture to the stars. When our solar system is all explored, the planets of other stars will beckon.